All right, let's look at exploration 3, but we're really only going to look at the first 3 parts of it right now. So exploration 3 reads, define a function f by a power series as follows. F of x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot 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 plus x to the n over n factorial, and then on to infinity. So the first part asks us to find f prime of x. Now we know that we can actually do this by doing term by term differentiation. So f prime of x is going to be equal to, well, the derivative of 1 is going to be 0. The derivative of x will be 1. When we take the derivative of x squared over 2 factorial, we're going to get 2x over 2 factorial. When we take the derivative of x cubed over 3 factorial, we're going to get 3x squared over 3 factorial. The next term is going to give us 4x cubed over 4 factorial. And then when we get out to the general term, we're going to get n times x to the n minus 1 over n factorial. And of course, that's going to keep going on to infinity. But I can do a little simplification here because of the factorials. So if you remember, what does 2 factorial equal? Well, it equals 2 times 1. How about 3 factorial? Well, that's going to give me 3 times 2 times 1. How about n factorial? Well, that's going to give me n times n minus 1 times n minus 2 all the way down to 3 times 2 times 1. So really I can do a little bit of canceling here because, for instance, with this term, 2 over 2 factorial is going to be equal to what? Well, 1. 3 over 3 factorial is going to be 3 over 3 times 2 times 1, which is going to be equal to a half. So really, I can rewrite f prime of x as 1 plus x plus x squared over 2 factorial plus x cubed over 3 factorial plus dot 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 plus x to the n minus 1 over n minus 1 factorial plus x to the n over n factorial plus dot dot dot. And what do we notice about this? What is this equal to? Well, it's going to be equal to f of x. That's kind of crazy. All right, well, number 2 asks us to find what f of 0 is going to be. And what's f of 0 going to be? Well, it's going to be equal to 1. So part 3 asks us, what well-known function do you suppose f is? Well, we need something that's going to be its own derivative, and we need something so that f of 0 is going to be equal to 1. Now, the only function that I know that is its own derivative is e to the x. So this series up here is going to be, whoops, equal to e to the x. And we can come back and talk about the other parts of this later on.